Welcome to solverfy.
This is chapter 27, problem number 64. We have a circular loop that has the charge Q that is rotated around an axis. So let's see, something like this with an angular velocity, and the radius is r. So then this rotation is going to generate the current, right? So for one revolution, the total charge is Q divided by the period is going to give us the current. Now that this loop is also embedded in an external magnetic field that is parallel to the surface of the loop. So this is the magnetic field. So then if we have current embedded in an external magnetic field, then there's going to be force generated by it, magnetic force generated by it, and the magnetic force is going to result in magnetic torque, right? So now let's just try and relate this period to the angular velocity that we have, because that's omega is what's given to us in the problem. So as you know, the period is 2 pi over omega, right? So if we substitute 2 pi omega for t, then we have q omega over 2 pi for our current. We also know that the torque vector is basically the cross product of mu and b, mu being the magnetic moment, right? And then the magnitude of this vector gives us the torque. Well, that equals to mu times b times sine of the angle between mu and b. So let's look what theta is for this case, right? The direction of mu, first of all, mu, before going there, mu is the current times the area, right? So whatever the normal of the area is, mu is along that direction. So area for us is pi r squared, obviously, and mu, depending on the direction of rotation, mu in this case is the angle between mu and b, it has to be 90 degrees. So then this sine 90 is going to give us 1. It's going to be simply mu times b, then the magnitude of the torque. And if we substitute for mu, it is going to be equal to I times pi r squared times b for torque. We also know what I is. Let's use this equation too. Q omega over 2 pi times pi r squared times b. Pi's are going to cancel out. We're going to have q omega b r squared over 2 for our torque.